We use these things every single day. But what's really going on inside this box? It's kind of a black box for most of us, right? Well, today, we're going to pull back that curtain. We're going to dive into the anatomy of a computer, from the actual silicon chips to the code that makes it all work.
I mean, have you ever really stopped to think about it? What is happening when you click on an icon or type out a sentence or fire up a game? It feels like magic, doesn't it? But it's not. It's all built on just a few fundamental and, honestly, totally brilliant ideas.
Okay, so the very first big idea, the one that everything, and I mean everything, is built on, is this really simple division. See, every single computer system, whether it's a giant supercomputer or just the phone you're holding, is split into two worlds, the physical stuff and the digital stuff. So on one side, you've got the hardware. That's all the physical parts you can actually touch. The screen, the keyboard, the chips buried inside. Think of it like the body of the machine. And then on the other side, you've got the software. These are the instructions, the programs, basically the intelligence that tells the body what to do. And here's the key. One is completely useless without the other. Here's a fantastic way to picture it. Think of a book. The actual pages and the ink, that's the hardware. But what about the words written on those pages? That's the software. Without the words, the book is just a bunch of blank paper, right? It's totally useless. It's the combo of the physical book and the story inside that makes it meaningful. All right, so let's pop the hood and take a look at that hardware, the body of the computer. And just like our bodies, a computer has a set of core organs, and each one has a super specific, super important job. First up, we've got the big one, the CPU, or Central Processing Unit. This thing is, without a doubt, the brain of the whole operation. It's this insanely complex little chip, packed with billions, literally billions, of tiny switches. Its job is to process pretty much every single command you give it. All the heavy lifting, all the thinking, it happens right here. Okay, next we have RAM. That stands for Random Access Memory. And if the CPU is the brain, then you can think of RAM as its short-term memory, or maybe like a temporary disk. When you open up a program or a file, the computer puts it on this disk so the brain, the CPU, can get to it really fast. But, and this is important, when you turn the computer off, that whole disk gets wiped completely clean. Then you have its cousin, ROM, or read-only memory. Now, this is a totally different beast. ROM holds the permanent, unchangeable instructions that the computer needs just to wake up in the first place. It's kind of like the part of your own brain that handles the automatic stuff, like remembering how to start breathing when you wake up. You don't think about it, it just happens. It's that essential. So let's just nail this down. The crucial difference is this. RAM is temporary. It's volatile, meaning it gets erased when the power goes off. It's for what you're doing right now. ROM, on the other hand, is permanent. It's non-volatile. It keeps its information, which is just those basic startup instructions, sometimes called the BIOS. So one is for doing, the other's for getting started. Okay, but wait. If RAM is temporary, where do all your files, your photos, your actual programs live for good? Well, that's the job of your storage drive. Think of it like a giant, long-term filing cabinet. For a long time, these were hard disk drives, those clunky things with spinning platters. But now, we've mostly moved to solid-state drives, or SSDs, which are way faster and more durable. This is your computer's long-term memory. Okay, so let's recap. We've got the body, we've got the brain, the CPU, we've got the temporary workspace, the RAM, and we've got the long-term filing cabinet, the storage drive. But a body without a mind is, well, it's just a pile of parts, isn't it? So now it's time to talk about the software, the ghost in the machine that actually brings it all to life. So software is just the catch-all term for all the programs that tell the hardware what to do, to make it actually useful. And it's basically split into two main categories. You've got the software that runs the computer itself, and then you've got the apps that we actually use. Think of it like a layer cake. At the very bottom, you have the physical hardware we just talked about. Sitting right on top of that is the system software, and the most important piece of that is the operating system, or OS. The OS is like the master manager, talking directly to the hardware. And then, at the very top, that's where the applications live. That's your web browser, your games, all the stuff we actually use day to day. The operating system, and we're talking about things like Windows, macOS, Android, iOS, it is the unsung hero of this whole story. Seriously, it's like a master translator. It takes our simple little mouse clicks and screen taps and turns them into super complex instructions that the hardware can actually understand. It's juggling memory, keeping track of all your files, and making sure all your programs can run at the same time without the whole thing just crashing. It's the ultimate office manager. So that brings up a really interesting question. How do we, as humans, actually talk to the operating system? How do we tell it what we want? Well, let me tell you, that conversation has changed a lot over the years. Way back in the day, you had to use something called a command line interface. This was basically a blank screen with a blinking cursor. You had to learn this whole other language of very specific, very complex text commands and type them in perfectly just to get anything done. I mean, it was powerful for sure, but it was also like having to speak a really strict, unforgiving foreign language just to, open a document. And then came the revolution, the graphical user interface, or GUI as it's known. All of a sudden, instead of typing all that complicated text, we could just use a mouse to point and click on little pictures, icons. This simple, visual, intuitive idea is what blew the doors wide open and made computers accessible to, well, pretty much everyone. And that evolution hasn't stopped. Not by a long shot. We've gone way beyond just pointing and clicking. Now, we literally talk to our devices, right? With dialogue-based interfaces like Siri and Alexa. And think about touchscreens. Every swipe, every pinch, these gesture-based interfaces are making our conversation with technology feel more and more natural all the time. So where is all this headed? What does the future look like? Well, all of these fundamental pieces we've just covered, the hardware, the software, the ways we interact with them, they're not just history. They are the essential building blocks for technologies that are right now completely changing our world. And maybe the biggest leap of all is artificial intelligence, AI. This is where things get really interesting. We're moving beyond just feeding computers a list of instructions to follow. AI is all about creating systems that can do things that normally require human intelligence. We're talking about recognizing patterns, making decisions, and even learning on their own.
And look, this isn't some far-off science fiction fantasy. AI is already here, all around us. It's the smarts behind self-driving cars, it's helping doctors spot diseases earlier than ever. It's the reason your streaming service knows exactly what you want to watch next. And every bit of it is powered by those same hardware and software principles we just talked about.
This foundation is also unlocking totally new ways for us to experience the world. You've got augmented reality, or AR, which overlays digital stuff onto your view of the real world. Pokemon Go is the classic example, right? And then there's virtual reality, or VR, which takes it a giant step further. It doesn't just add to your reality, it completely replaces it, dropping you into a whole new digital world. So when you step back and look at it, we've gone from a simple split between physical hardware and invisible software to a future where our physical reality is literally blending with the digital world. The pace of change is just staggering, and it really makes you think, doesn't it? As these basic building blocks get even smaller, faster, and smarter, what part of our world will they completely transform next?